Okay, so let's start. My name is Suraj Borate. I am PMRFTA for the NPTEL course Introduction to Robotics, and today we will be discussing week 6 of this course, and we will try to solve some previous year's questions that can help you in solving this year's assignment. So, to begin with, let's directly go to the question 1. So a DC motor has an armature resistance. So we have been given the resistance. So today's assignment is quite easy. Uh, it's mostly plug and play formulas. Okay, and some conceptual questions. So we have been given resistance as zero point 0.4 ohm. The back EMF constant is given as 0.3. But it's going across. Okay. And the motor is connected to a fan blade. So you are able to hear my voice clearly?
Yes, yes.
Still has earphones. So now you are able to hear? Hello?
Yes, yes,
Okay.
yes.
The motor is connected to a fan blade whose load characteristic or the torque equation is given by this relation. So where omega is the speed in radian per second. If it is intended to operate the fan blades at a speed of, let's say, 60 rpm, omega equal to 60 radian per second, determine the armature input voltage. Okay, so we have to find out what is the value of VA. Okay, and so any guesses like how we should approach this question? So what all things we can find very easily? Anyone wants to try? So we know K, right? We know TL, we know omega. Okay. So first of all, okay, we know K and we know omega. So let's find the value of back EMF. Okay. So what is this? This is K into omega, right? So zero point 0.3 into 60. That will be how much? 18, right? And we have been given TL is equal to 0.02 into omega square, so that is 60 square. So how much this will be? What is the value of TL? Anyone? Is it 7.2 Newton meter?
7.2 Newton meter.
Yeah. And so if we want to find from T, we know TL, we know K, so we can find the current, right? How do we find the current? What is the formula? Anyone? Right? So what will be the current? 7.2 divided
Torque
by.
by constant.
So what is this value? 24, right? So now we have all this. So how do we find the input voltage? We have the current. We have the back EMF. We know the value of resistance. So what equation do we use?
So we leave
Anyone?
voltage as the subject of formula and find out the value.
Yeah, what is that
Yeah, what is
formula?
formula?
V is equal to current of armature times resistance of armature plus back EMF.
Yeah.
Yeah.
So if you do this, you substitute uh, 24 into resistance is zero point 0.4 plus EB we found out to be 18 volt, and we get VA to be whatever the answer is there. So almost 27.6 volt you should get. Okay. Fine. Any doubts in the first question?
No, sir.
Okay. So let's move on to the next question. Okay, a DC motor has armature resistance again zero point 0.4 and back EMF constant is the same 0.3. The motor is connected to a fan blade. Okay, did I? Okay, it's fine. TL is given. Okay, so the armature terminals of the motor are energized by the step down converter, and which in turn is fed from a 48 volt DC source. So now it is like we know that the DC source is 48 volt. If it is intended to operate the fan blades at omega equal to 60 radian per second, determine the on duration of the switch in microsecond if the switching frequency is chosen to be 8 kilohertz. Okay, so now how do we do this? So what does the switching frequency mean? So if we are actually if you remember the concept of duty cycle, so for some percentage of time the motor remains on, and for some percentage time it remains off. Okay, so if you see the total duration, okay, so that is called T. Okay, and 1 by T is the frequency of the or the switching frequency of switching. Okay, so we have been given frequency, and then we can find this time from the frequency by taking 1 by f, right? And once we get the time, right, once you get the time, then what you can do with it? Okay, so we have to determine the on duration. On time we have to find out. Okay, so on time, if we go reverse, on time divided by the total time will be our duty cycle, right? Now this duty cycle is also related by voltages, correct? So we have our source voltage as 48 volt. Okay, so we have our source voltage as 48 volt, and how much is the voltage that appears at the motor? That we have to find out, correct? And then we can get the duty cycle. So we have something here, and if we find out what it is here, then we can, because we know this. No, we don't know this, right? We don't know this. So from here we will know D, and from that we can find the odd time. So that kind of thinking we can use, right? Anyone has any doubt?
No, sir.
Okay. So let's try to solve this. Okay, so F is equal to 1 upon 8 into 10 to the power 3. So, uh, sorry, T is equal to 1 upon 8 to the power 10 to the power 3, because this is the frequency 1 by F. So that comes out to be how much? 125 microseconds. You can check this, okay, because this is 0.125 into 10 to the power minus 3, that will become 125 into 10 to the power minus 6. So this is 125 microseconds, right? Okay, so now what is the value of uh, duty cycle? We need to find the value of duty cycle. How do we find the value of duty cycle? So for that we need this VA, right? VA. So how can we find the value of VA? So if you see the previous example, what we get? 27.6, right? So can we put that 27.6 over here or not? Everything is same. Someone tell me the value of duty cycle, how much it's coming. Calculate. So are you guys trying to solve or there are doubts? So 27.6 divided
27.6
by
divided
48.
48.
0.575. 0.575.
0.575.
0.575.
Good, good. So once we know D, so that was our logic, right? Once we know D, now we just have to apply on time upon capital T is equal to D. So what is the on time? On time is equal to 0.575 into capital T. So capital T was 125 microsecond, right? So how much? What is the final answer?
71.8 microseconds.
Yeah, 78 1.8 microsecond. So anyone has doubt? Do you want me to repeat? Please let me know. Okay. So let's move on to the third question. Yeah, a DC motor has armature resistance R is equal to zero point 0.5 ohm and an armature inductance L is equal to 1 millihenry. The back EMF constant is given by 0.5 volt. The motor is connected to a load which has this 0.002 omega square. Okay, so the armature terminals of the motor are energized by this switching frequency as F is equal to 5 kilohertz. Okay, and the source voltage is 100 volt DC. Okay, that's very high. Okay, determine the peak to peak value of ripple in the armature current when the fan blades are intended to operate at this 60 radians per second. So we have to find the if there is a ripple in the current. Okay, so what is the difference between the maximum and the minimum value of the ripple? Okay, we have to find delta I. Okay, so any idea what formula we can use for this or how to approach this? So what is new in this problem? Okay, first of all they have changed the value of the resistance. Okay, and they have also added the armature inductance. In earlier problem, there was no inductance, correct? So now it is
Now
like
it
now it is something like this. So there is some inductance, there is a resistance, right? So it is not just the resistance, but there is also inductance. Okay, and now this is the voltage that we are interested in, VA. Okay, so how do we approach? Is there any relation between delta I and L? So the drop about the inductance is
So delta I is equal to voltage of G minus voltage of A divided by LA times duty cycle into time period where it's on.
okay. Can you
okay.
repeat
Can
what
you
you
repeat
said?
what you
Delta I
said?
equal
Delta
to?
I equal to?
I'll write it down.
I'll write it
V
down.
of G
Vg.
Vg
minus voltage of armature divided by
Hmm.
inductance multiplied by duty cycle into time period TS.
Okay.
Okay.
So
So
how did the formula come? Anyone?
It's actually making I as the subject of formula. Originally, it is L equals to.
Acha.
Acha.
Yeah, but that
But
formula how
that
it came?
formula how it came?
Okay. So it
Okay.
is
So
like
it is like
L di by dt, right?
Yes.
right.
So this L di by dt is equal to what? It will be Vg minus Va, right? Now if we consider for only for the that time, okay, only the cycle time, okay, then we can say that for how much time the motor remains on is d into t, okay. This d into t is the time the motor has remained on, okay. So sorry, let me write like this. So L delta I upon d into t, I can write this like this, okay. Why? Because this much was the change in the current in the time it was on, d into t, and so now I can say delta I is equal to j minus va to dt divided by L. Okay, let me check my notes. Yeah, so this is the reason why we are getting this formula, okay. So now let's proceed to solve this question. So what all things we have? Okay, so what is what we don't have in this formula?
We don't have I, sir. We have to calculate I. We have inductance, we have resistance, we have scaling factor, then we have T of I torque, frequency,
No, no,
and
no.
from
No, no,
In
no.
in this
In
particular
this
formula,
particular
what we
formula,
don't have?
what we don't have?
We have L,
We have L,
right? We don't
right?
have
We
T,
don't have T,
but that can
but
come
that
from
can come from
1 by F,
1 by F,
yes, yes,
right?
right?
yes,
Okay.
Okay.
We have
We
VG,
have
100 volts,
100
right?
volt, right?
yes.
VA we have
VA we
or
have
not?
or not?
No, we have to calculate that, sir.
Yeah, so VA we
Yeah,
have
so
to
VA
calculate.
we
And D how we will calculate? Or we have D?
have D.
once we have VA, then we can take D as VA divided by VG.
Right, right. So
Right,
that
right.
that
So
is how
that is
you
how
think.
you.
Okay. So now just anyone quickly solve this and tell me. Okay. I will solve parallelly with you, and you guys also solve. Okay. So let's see.
So in this step, we'll also use the back EMF formula to find VA.
Yeah.
Yeah.
So
So
how do we use that? VA is equal to IARA
IARA.
plus EB, right?
Yes.
Okay.
Yes,
So
sir.
Okay.
now what
So
is
now what
EB?
is
K into
K into
0.02.
0.02?
What
It's
is it?
30.
What is it?
0.002.
0.002?
It's 30.
Yeah.
Yeah.
Omega square. So we get this value as 30. This will come as 30. What about IA into RA? IA, how we will get? We will get IA by 0.02 omega square divided by K. K is given as, what is the value of K? zero point 0.5 this time, right? Into RA. What is the value of RA? No, so K is 0.5, RA is also 0.5. Okay. Okay, can anyone tell me how I wrote this? So this is torque upon K,
K.
Yes, torque
right?
divided by
Right?
6.5.
Yeah. So
Yeah.
because we have solved two questions, I am trying to show you how you can directly see the end formula, see what we don't have, and then think about their formulas, right? So here I wrote we didn't have VA, I wrote VA formula. Now we didn't have EB, so I wrote EB formula. I didn't have IA, so I wrote IA formula. Okay, that way you go on solving. Okay, so if you put the value of omega over here, then VA turns out to be 37.2 volt. Okay, put omega as 60 rpm, sorry, 60 radian per second. And once you get VA, what was the, why were we finding VA? To find D, because it is D is nothing but VA by VG. So 37.2 divided by 100, and we get as 0.372 as D. Okay, now we have everything except the capital T. So capital T will be 1 upon 5 into 10 to the power 3. So that is nothing but zero point 0.2 microseconds. And so now let's find delta I. We have everything. So 100 minus 37.2 divided by, what was the value of L in the question? 1 millihenry. Okay. So 1 millihenry can be written as 10 to the power minus 3, right? And so what is remaining? 0.372 duty cycle into zero point 0.2. So if you do the calculation, you should get the answer as uh, some 4.67. Let's check. Are you getting? Okay. If you go get something else, let me know. I'm not able to access this area. Okay. Yeah. Any doubt in this question? This was little bit lengthy. It used all our formulas. Okay. Fine. Can I move to next question? Hello, are you there? Can you hear
Yes,
me?
sir. Yes, sir.
Okay, so I can move to the next question.
Yes, sir.
Yeah. So if we go to the fourth question, there are a couple of theory questions. So a permanent DC motor, a permanent magnet DC motor, supplied from a buck DC-DC converter runs at a certain operating. So what is a buck converter? What is its function?
Step down DC voltage.
What?
Step down DC voltage.
Yeah, step down DC voltage. So mostly if you see in robotics, what happens is there are a lot of components like let's say a microcontroller or microprocessor. Let's say you are using Raspberry Pi or an Arduino, okay, or you are using a Pixhawk flight controller. So these things don't operate at the voltage that is provided by the battery, because the battery has to do two things. One, it has to provide voltage and current to the high powered uh, things like motors. Okay, so motor will operate on 12 volt or let's say 24 volt or something like that. But these electronics will operate at 5 volt or 3.3 volt or something. So we need a way to reduce the voltage from 12 volt to let's say 5 volt, and then supply this to Arduino. If you directly supply 12 volt, then it will destroy the Arduino, okay, or the any microcontroller or any electronics. Okay, for motor you can provide directly to the motor driver 12 volts and all. Okay, so that is why we need this buck converter. Okay, sometimes we also need boost converter. Okay, so the boost converter, what it will do is it will increase the voltage. Okay, and okay, so let's that's all about the converter. Okay, while the load torque remaining constant, if the operating speed is decreased. Okay, so what happens if the load torque is remaining constant and the operating speed is decreased? Okay, so you know the current relation, right? T is equal to Ki. So this is, if this is constant, K is constant, I should also be constant. Okay, so but if the speed is reduced, then what happens? If the speed is reduced, then the back EMF is affected, right? And if the back EMF is affected, then that affects the armature voltage, right? So an armature voltage is affecting what? Is affecting the duty cycle. Okay, so duty cycle was VA by VG. Okay, this is constant. Okay, if this changes, then D and VA are proportional. Okay, so now what is the formula that relates EB and VA? VA minus EB, or let's say IA RA plus EB upon VG is the duty cycle, right? So if omega reduces, EB reduces, right? IA is constant, RA is constant. IA is constant because torque is constant, and VG is constant. Okay, so what is happening to duty cycle? Sorry, duty ratio. Duty ratio is also decreasing, but the current is constant, right? Any doubts over here? So that is why the average remains current same and the duty ratio decreases. Fine. If you have doubt, then let me know. Let's move on to the next question. Consider two design variants of DC motor. So one is the permanent magnet DC motor and wound field DC rotor. Okay, this we discussed last time also. It is very similar to the question that we discussed last time. So you know that what happens in the wound magnet. So there instead the stator field, okay, that was generated by the permanent magnets is now generated by coils. Okay, and to fit the coil and all, you need bigger space. So this particular arrangement is bigger than the permanent magnet arrangement. Okay, because there are simply because there are more components. And secondly, what happens over here is why do we do this? Because we want to operate the motor at higher speeds, but we cannot go to higher speed beyond a certain limit, right? In the permanent magnet motor. Okay, then what you do is you to do that you want to change the uh, this field. Okay, so if you want to change the field, you need to control it, right? So to control the field, so B was constant, right, in the permanent magnet DC motor. But now if you change the B, then you can affect the RPM. Okay, okay, so that was the logic. Okay, so let's see what is the option. Overall size of A is smaller than B. A is permanent magnets. No, right? That is not the answer. Okay, wound field motor is bigger. Okay, yeah, that is the correct statement. That permanent magnet is smaller than the wound field. But we are asked to pick the wrong statement. So that is why this is not the answer. Actually, it is the correct statement. Okay, it is feasible to operate at speeds above the rated speed, as I said, for wound field. Okay, while it is not a no, no, no. Okay, okay. So this false thing confuses. Okay, so let's first check the trueness of the all the statements, and then we will say what are false. Okay, so let's check. So at speeds above rated speed, can we operate a permanent magnet motor? No, we cannot. Okay, why we cannot change the stator field? That's why. Okay, but B we can. Okay, so this is a clearly a false statement. Okay, commutator and brush assembly is required for B but not for A. Okay, first of all, for both B and A, the commutator and brush assembly is located on what part of the motor? Anyone? Hello? What part of the motor the commutator and brush assembly is there? So what is the purpose of commutator?
Is it
Yes?
stator?
No, it is on the rotor, right? So the purpose of the commutator and bus assembly is that you should allow the entire coils to rotate without tangling among each other, right? So, and that is why this commutator and brush assembly is there. Okay, so the coils rotate, okay, and still they get the voltage that is coming from the external source. Okay, so it is on the rotating part. Stator anyway didn't have any relation with the commutator because it's not rotating, it's stationary. It's stationary, so it's called stator. Rotor is called rotor because it's rotating. Okay, so this has nothing to do with whether it is permanent magnet or stator or the wound field magnet. Okay, so this statement is also false. The rotor design of A and B are alike. True. Right? Rotor is same in both of the this thing. Okay, so this is the answer. Okay. Let's move on to the next questions. Okay. The speed of DC motor is controlled till its rated speed. Okay, what do you mean by rated word? This word rated. So this word rated means that above that if you cross. Okay, so if you see any component when you buy online, then you go to its data sheet, and in the data sheet you find this rated torque, rated current, all this stuff. rated voltage. So it means that if you cross that thing, we don't give the guarantee that it will work properly. It may damage itself. Okay. So the DC motor is controlled till its rated speed, or you can also say it may not work optimally. Okay. So there is also something called as peak current and peak voltage. Okay. And then there's rated voltage, or the nominal voltage or nominal speed also. So this this is the operating speed of the motor. Now, by adjusting the armature terminal voltage by a suitable mechanism, okay, what we have to say, the speed of DC motor is controlled till its rated speed by adjusting the armature terminal voltage by a suitable mechanism. In this case, the maximum torque that can be generated for a given speed can be arrived from the consideration that power is constant. Okay, the torque generated remains constant at all speeds till the rated speed. Okay, the maximum torque that can be generated is constant at all speeds till the rated speeds, or the torque generated increases at the as the speed increases from 0 to rated speed. Okay, so how do we approach this? So there is this motor characteristic curve, right, where we have the torque capacity, that is nothing but the maximum torque that can be produced. Okay, and on the x-axis we have the angular velocity. And so what is this particular line represent? Can anyone tell? This particular value, what it is? This is the rated speed, right? So if you go to this lecture, you will find, okay, that this how this graph came and all. Okay, now this is till here we have a certain value of magnetic field, okay, for which we are getting this torque capacity. Once you cross the rated speed, okay, what happens is, as we had discussed for wounded field, okay, your magnetic field has to reduce, right? So here you can see this. So once the magnetic field reduces, the effect comes on the torque, okay, and so the torque capacity also reduces. Okay, so till here the maximum torque is capacity is constant, like the maximum torque that can motor can give is constant, and after that it reduces, after the rated speed it reduces. Okay, so that is the answer. Okay, so here they are saying torque generated, not the torque capacity. Okay, this graph is about the torque capacity, so that is why this is wrong. Okay, and the first question they are saying maximum torque that can be generated for a given speed, okay, can be arrived from consideration of power is constant. So this statement is also wrong, because not maximum but the torque that can be generated at a given speed can be, so you can say tau omega is constant, not tau max into omega is constant, right? When we say force into velocity is power, right? Similarly, torque into angular velocity is power. Okay, but here this is not tau max, this is tau, so this is just t. Okay, so okay, so now the torque generated increases as the speed increases from 0 to rated speed. Okay, so we don't have any relation directly between torque and the speed. Okay, so torque depends on current only. We cannot comment directly based on the speed for the torque. Okay. The purpose of, okay, this fine. Actually, once you see this answer, it's very clear. Once you see this graph, you can directly know this is the answer. The purpose of a freewheeling diode. So what is a freewheeling diode? So if you have something like some circuit like this, there is a switch. Okay. So what does freewheeling diode do? So when you are this switching is happening, okay, when the switch turns off, what happens is the all your back EMF current and all can flow through this. It gives a circuit for the, sorry, when the switch is open, the back EMF can flow through this path, the back EMF current and all. Okay, so the reverse current can flow. It gives the possibility of that. Okay, the freewheeling diode. Okay, so even when the switch is off, this is possible. Okay, so the ensure that the current in the inductor is in the closed path when the main switch is off. Okay, any other, any doubt? Yeah. So let's go on to the last theory question, and then we have some more numericals. Okay. So in a DC-DC converter, if the switching frequency is decreased while maintaining the duty constant, so what is the switching frequency? So we have T on upon total T is equal to duty constant, right? So this is T on into F, 1 by T, we can write as F, 1 by T is F. Okay, so what they say is that switching frequency is decreased. You decrease the switching frequency and this is constant. Okay, so what happens? So we have to increase the T on, right? T on should increase. If F is decreasing, T on should increase, then only the D can remain constant. Okay, so the average value of output voltage decreases. No, if T on is increasing, right? So T on increases. Okay, that means what? VA by VG, VA should also increase, right? So the average voltage value of output voltage remains constant. Average value of output voltage decreases. Average value of inductor current reduces. Okay, okay. So the switching frequency is decreased while maintaining the duty cycle, duty ratio constant. Okay, can anyone tell me what is the logic? What should be the answer? Are you able to read the options or it's too small? Now you can see. Okay. Tell me why this why the average value of output voltage should remain constant. Anyone? So the switching frequency is decreased, means capital T is increased. Okay. Anyone? So if T increases, if D has to remain constant, T on should also increase, right? Or when VG is always constant, right? So VA has to be constant. Are you getting what I'm saying? Hello?
Yes, sir.
Yeah. So if you see T on should increase. If T increases, T1 should increase, but that doesn't mean that VA should be affected by that because VG is constant. So VA will be constant. Okay, because the D is constant. So our this average value of the voltage remains constant. Now peak to peak ripple, that formula we know, delta I is equal to some terms over here into D, right, into T. So we had some terms over here and then we had D into T. Now D is constant, right, and this T increased. So delta I should increase, right? So this is the answer. Okay. So the formula, if you don't remember, it was Vs minus Va by L into D into T. Okay. So these all things are constant. D they have given as constant. So T is increasing. So delta I is increasing. Why T is increasing? Because the frequency is decreasing. That's why T is increasing. Okay. So let's move on to the last few, what we say, questions. Okay. So this is very easy. A permanent magnet DC motor is supplied with an H bridge DC-DC converter. Okay. So what is H bridge? So you have some four switches, right? Some four switch arrangement is there. Okay. And then they are connected in a clever way, right? Okay. So input voltage to the converter is 48 volt. Okay. So and they have said that 1 and 4, 1 and 4 is the top and bottom of the first leg, and 3 and 2 are the top and bottom of the second leg. Okay. And then when 1 and 2 are 1 and 2 are operated together, right? So the current actually flows. So how is the diagram of H bridge? Okay. So what how this is connected? What is the component over here? Hmm?
There's a DC motor.
There is
DC motor.
DC motor. Okay. So now what happens is 1 and 2 operate together and 3 and 4 operate together. Okay. And what we want to do is we want to find if the average voltage required by motor for operating at a particular speed is 16 volt, determine the duty ratios of the switches 1 and 2. Okay. So let's say this is on and this is off. Okay. So what is the, we have to find the duty ratio. So how do you find the duty ratio? So there is this 16 volt and input voltage is 48 volt. So Vg is this much and we want that V voltage across the motor is that 16 volt we want. So how to approach this problem? Okay, this you can help me.
So if VA and VG are given according to H bridge formula,
Yeah,
VA by
what?
VG is equal to 2D minus 1. We can use that formula to calculate.
2D minus
2D
1.
minus 1.
And that is for your switches 1 and 2.
Okay, so
Okay, so
why 2D
why
minus 1?
2D minus 1?
Basically, there are two duty cycles. Two switches are monitoring the duty cycles.
Then why
So
Then
minus
why
1?
minus 1?
we have to omit the other two switches duty cycles. They are 3 and 4.
Okay, that is
Okay,
not
that
very
is not
clear.
very clear.
Okay, so basically what is happening over here is the there is okay, 1 minute. You can just rewrite this 2D minus 1 as now. Can this make sense with you?
Yes.
Okay, so what is happening is this is for 1 and 2. Okay, so total time is constant, right? So total time, let's say, is 1 unit. Okay, the cycle time is 1 unit. So for d amount of time, 1 and 2 are on, and for 1 minus d amount of time, 3 and 4 are on. Okay, but here the voltage is in opposite direction. That's why minus sign. And if you want the average voltage, average, what is the average thing? Then I have to add this up. So this will be d minus 1 minus d. So this is the negative amount of negative voltage, and this is the positive voltage, and we are taking the average. So this is the intuition behind this formula. If you open this bracket, you will get 2d minus 1. Now you understood? Is
Yes.
anyone has
Is
doubt
anyone else?
how this formula came? So just let us calculate now. So VA by VG is 16 upon 48 is equal to 2d minus 1. So 16 by 40 is 1 by 3 plus 1 2d, right? So this is 4 by 3 by 2 d, so it is 2 by 3. So that is why it is 0.67. Done. And similarly, you can solve the second question. It is exact same way to solve. The only thing is here they have said out now that they have given us the value of switching frequency. Okay, so the value of switching frequency is what? T on upon T is equal to D, right? Okay, so they have given us what? 10 kilohertz. So this will be 1 upon 10 into 10 to the power 3. D value is what? D value is 0.67.
Point.
So that will be 10 into 10 to the power minus 3, na?
No, it is
No, it
kilohertz,
is
na? Kilohertz. So it is 1
10
It is
upon
one.
10 into 10 to the power 3. 1 upon, right? So if you now do uh, the calculation, T on will come out to be D is equal to
D is equal to
0.67
0.67.
into 1 upon 10 to the power 4. Oh, there is some mistake, right? Here.
Yes.
Okay, they have asked
Okay,
for
they have
switches
asked for
3, 4.
switches 3, 4.
Okay, they
Okay.
have asked for 3, 4. So this will be not 0.67, this will be 1 minus 0.67, right?
0.33.
Right?
Yeah, zero point 0.3.
Yeah, point 3.
0.33 into this uh, divided by 10 to the power 4. So this will be 33.3 into 10 to the power 6. So minus 6, sorry. So it will be 33.3 microseconds. Fine, everyone?
Yes.
Okay, if there are any doubts, you tell me or we can stop the session.
Just a few questions, sir.
Yes, yes.
Yes, yes. If we are given questions for expressing PM ratio, inductance ratio, then what formula we will we consider? The inductance formula only.
Inductance ratio means
Inductance
what?
ratio means what?
I don't
Uh,
get your question.
Get your question. For two different motors, if there are two different inductance values,
Okay.
armature inductance given. So
Hmm.
in that situation, if
Hmm.
they ask us to give inductance ratio, value of inductance ratio, so will we consider that L into di divided by d into t, that formula all the time, or is there any other formula
I
apart
think
that
if
we can? I
they
think if
give you the inductances values, then they will ask you some other ratio, not the inductance ratio directly, because then you can directly take a ratio, na? If but yeah,
But yeah,
that is one of the
that is one of
formulas
the
where
formulas
the
where
inductance comes and you can use it. If they are asking some, like let's say they give you the peak ratio for one motor and peak ratio for another motor, peak current ratio, and then they
and
ask
then they ask
for
for
inductances,
inductances,
then you can use
then
it,
you can.
something like that.
Here they ask peak to peak ripple, so that means we have to take delta I value.
Yeah, yeah.
Yeah.
So don't ask directly from the assignment question. Okay.
No, no, I'm not explaining any
Huh.
question. I'm just saying if
Yeah,
we
yeah.
get four questions like that,
Yeah,
what would
some
be our
question if
yeah,
you
some
get like
question if
that,
you
then you can do. But only thing you have to pay attention to is that other parameters in that formula are constant. Only then you can apply. Okay.
okay. Got it.
Hmm.
Hmm.
Any other question?
Sir, when we shall continue second assignment of sixth week?
Second assignment of sixth week means what?
मतलब वो अभी जो हमने किया वो प्रैक्टिस का था ना, प्रैक्टिस वाला, और अभी एक दूसरा क्विज.
वो इसलिए दूसरा क्विज नहीं किया क्योंकि आपका अभी सबमिट नहीं हुआ है ना, क्योंकि
अच्छा.
आप और वो क्वेश्चन सेम है उसमें और इसमें, मतलब प्रीवियस ईयर का जो मेन क्वेश्चंस था are
ओके.
actually repeated, so that's why we are not solving those questions this time.
ओके.
Hmm. Okay, so if there are no questions, then today we can end the session little bit early, quite early actually. These 2 weeks are quite easy in terms of scoring, because they are mostly conceptual questions plus formulas, and very short questions are there compared to what we did in DS parameters and all. And let's see what comes next week. Okay, till then, bye. Okay, let's meet
Thank
on
you. Okay,
Sunday.
let's meet on
Yeah,
Sunday. Yeah.
Thank you, sir.
thank you.